So very good morning to all. Graduation. This is by Norman Lewis. This is one book you refer from, any clerical exam to IAS exam. One book which contains 60% or more of your questions about vocab will come from this one. For example, it speaks gen means birth, con means with. So con generic means right from the birth. Right from the birth means the things are different. The effect is different from the birth itself. So what will be the meant by the non-congeneric? Non-congeneric means the effect is not different, effect is the same. Same effect everywhere. If I got one IDV, one DV, one control variable, and then I have something like common method biasness, the biasness will have effect on all and to the equal extent. If you say no, I have a congeneric approach. Congeneric approach means the effect will be different on all of this. Okay, so we'll check it out whether the effect is same or different. I assume, well, I don't know whether effect will be there or not, but let's see whether Harman single factor can tell it. So those who have attended any of my workshop where we do the complete check the anatomy of factor analysis, we do the dissection of factor analysis, I show where from this is actually made. So they might be able to understand it quickly. Let me work on two factors only. Satisfaction leads to loyalty. So in the whole of my discussion, I will use only this data file demo, and only one thing I will work on: satisfaction leads to loyalty. Only two variables, one dependent, one independent. Let me quickly go through the factor analysis and let me check satisfaction and loyalty. So Harman single factor approach says that run the factor analysis, click on the extraction, and fix factor, only extract the one factor. Only extract the one factor, nothing else. Don't click anywhere else, and see how much is the variance explained by the first factor. 51%. If it is majority, again not defined where it is majority, but more than 50%, there means there is a presence of single something is there. Single factor is more dominant because of the common method biasness. So you say biasness is present. Now, if you know little about the statistics, this is just an interplay of how many constructs you have. The more will be the construct, the first factor will be little diluted because that effect 100% will be separated among all the factors. The first rule, how many factors are generated? As many statements are there. If 9 statements are there, just check it out. I have 4 statements from the satisfaction, 5 from the loyalty. So 9 statements are there. So 9 factors are extracted. So we can assume 1 by 9, that is everyone should be 11%, but first one is very, very high, 51% variations it is explaining. Now, if what I will do, I'm just playing with it. I have put the 4 factors here, and still I am saying extract 1. And how many statements are there now? Number of statements are 21. So if number of statements are 21, how many factors will be extracted? Initially 21. On an average, how do you think how much one factor will explain? Almost 4 or 5%. Okay. Now first see, it explains 39% or 40%. This time we will say that Harman single factor says there is no presence of common method biasness. Are you kidding? Are you just joking? What is it? The same thing, same variable here also, here also. It means if you work with the 2, then there is a common method biasness. If you work with the 4, biasness is not there. No, you are just playing with the analysis. If you know about the factor analysis, you know if I take 20 more, this will be reduced from 40 to maybe 20 or 25. Single factor, first factor is almost the most important. Agree. But that also depends on how many factors are there. If you take 100 statements, this will be hardly 15-17% or 20%. So that means the common method is not present. And if you take few, the common method is present. Absolutely, absolutely nonsense. It makes no sense to use the Harman single factor. That's why I'm really shocked that even my friends are using it when they are getting the publication in the A category. That's okay, because the reviewer is also don't know it. Publication is not the crux. Crux is, are you just, do you know you are playing with the statistics? Do you know this is nothing? In better, you say, I don't know what our common method biasness. So Harman single factor is Practically nothing. People have rejected it. When you study about this literature, people have rejected it. Still, so many people, even in the 2021, you will find papers of the wonderful professors, they have used the Harman single factor. And when I ask them that what exactly this is, they say, we have to use it, we have to write a line. This is precisely what they told me. We have to write a line that common method was checked, and we wrote and it was accepted. Well, that's not the point. that's not the point. It's not something like sort of making checklist and doing simple check. No, please try to understand the real philosophy, and that will only take you to the higher end journals. So what the other people did? Other people said that we will use another technique, and name of the technique is partial correlation. Now, partial correlation is a fantastic technique. What it says, partial correlation approach that says that relationship between the two is always affected by something else. Always affected by something else. So in all my workshops, I show never ever trust R. Yesterday, I gave example. As the weight of the participant increased, IQ was found to be very high. No relation between weight and the IQ. Actually, because of the age, weight was increasing for the babies. Because of the age, IQ was increasing. So my question is, what is the real relation of weight and the IQ, taking away the effect of age? Now, can I ask you that I will conduct a study on weight and IQ tomorrow, and tomorrow none of the participant will bring his or her age. Please leave your age at home and then come here. And I have seen that gender also has an effect on weight. So don't bring your gender also. Put your gender at home. Can I say this? Does this make sense? No. So what I need to do? First thing is measure it. These will be called as the control variable. And we always start with the first thing is you measure it. Friends, please focus on this word measure. Anytime you go for the lectures of quality, Six Sigma, quality improvement, anything, and their punchline is you cannot improve something which you can't measure. If you can't measure, you can't improve. First thing you need to measure. That's why NIF we have started. We started with NBA, we started with this. There are every reason you to object that how can you rate the quantity. A teacher is teaching. How can you give some sort of rating to the teacher? How can you compare the two teachers? Yes, I agree. But still we need to measure it. By whatever method, we need to measure it. This is the keyword. More important than anything else in the entire research. And ensuring you are measuring only that thing. No other biasness is there. So how to do that? Measure the age, measure the gender, and then control them and find their correlation. This is called as partial correlation. That's a fantastic thing, partial correlation. Taking away the effect of the two, controlling the effect of the two, the real relation, and you might find it's almost like zero. How to do it? So people said there is a X, there is a Y. What we will do? We will measure something else. Now something else can be measured in three methods, partial correlation approach. One, they said, we will measure it as a number, like social desirability. And you will be really surprised to see the very initial, what it was? What was the thing they measured? Shoe size. What is your shoe size? Now, certainly your shoe size has nothing to do with your leadership and the motivation, the opinion you are providing. Okay. They said we measured the shoe size also. I don't know how shoe size will be affected by common method biasness, but they said shoe size will be taken and its effect will be controlled for both. But people said, well, don't share jokes like this. Social desirability was one that was used by people. Then it was the positive and the negative effect scale, PENAS. There was taken, others were taken. So it is number one, either you take anything else you measure. Again, can you see it's a priori? A priori means you do it at the time of data collection. Don't do it later on. But a priori was less prevalent at that time. I'm talking about the 80s and the 90s. And most of the people were working on the post-hoc. Post-hoc means now I have collected the data. Now tell me, is there any method if I think can do anything? So here, Professor Gaskin popularized, actually this was by, the technique was there, ULMC. Unmeasured means it's a post-hoc. You are not measured at the time of data collection. Latent variable approach. Latent means it's not something like a variable, it's a circle. It's a circle, you will measure it. Now, how to measure it? I have not measured at the time of data collection. Don't worry. Professor Gaskin says, if this is the case, satisfaction and the loyalty. So what you should do, you please make one construct. Okay. Now making the construct one, number one, it's a post hoc approach, right? Because we have not collected at the time of data collection. Second, it's a latent one. So, but as is the rule that none of the circle can exist without a box, means you cannot ask something. There need to be any statement. How to go along with that? Connect this one with all of these one. Satisfaction 1, 2. Try to understand. Now you need to little bit know about the basics of MLE method, maximum likelihood estimation. In the maximum likelihood estimation method, we start with first making a value of satisfaction. And then with the help of this, we predict about the satisfaction value. Now one value we will predict and one value is actually available, which my user said. And one I will predict. Since it is a reflective scale, if satisfaction is able to predict, and these are very much similar, satisfaction will be able to predict second also, third also, fourth also. So in general, we say satisfaction is made up of the 4, but in actual, technically in the MLE method, we make the statement on the basis of satisfaction. Now, these 4, satisfaction is able to answer this, loyalty is able to answer this, but now I am saying, no, there is something else which is made up of all of these. So you need to put a one-sided arrow with everyone like here, 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 and one-sided. So Professor Gaskin said, I have gave a plugin. The plugin is, what is the plugin? Common Latent Factor Connector. So if you are a user of Amos, I am sure you must be using Professor Gaskin plugin. They make life very, very easy. So simply it says, click on it once, click on the plugin, common, and this thing will come directly. Otherwise, you just click yourself, right? And then run it. So once you run it in the absence, one you run in the presence of it. Let me check it. False. Let me run it in the absence of common method biasness. And I will note down the values, which values? I will note down these values of the estimates and the regression weight. Regression weight I am noting down. So copy and take it to Excel. Let me take the regression beta also, this one, and take it here also. Now I will say, what if I assume that there is a common method biasness, then what will happen? I put a circle, select the circle. It's important to select the circle before clicking on this plugin, Common Latent. So if you don't have this, then refer to the Professor Gaskin's video, where from you can download, where from you can activate it. Run it once again, proceed, and check these things once again, estimates. Let's take it to Excel. And let me take that part also to the Excel. In the estimate, I have the correlation, standardized weight. Okay, now how to evaluate it? We will evaluate it simply by looking at, we don't require all this stuff. We simply require it when there was, this was the case, when satisfaction leads to, oh, sorry, I think I made a mistake here. The mistake is I need to compare this value with these values. Check it out, satisfaction initially, let me zoom it a little bit. The value was 1, 1.2, 1.22. Now the values are negative. Okay, and it's very high. These are negative and insignificant also. Loyalty is okay, CLF is okay. And then Professor Gaskin says, if there is an effect on this of the order of more than 0.2, then it is considered. I'm not covering it in much detail because this is now useless concept. People don't use it. But I'm just trying to tell you, this is how this was done. This was done that you have it. Because yesterday somebody was asking that now I have collected the data. Can I use anything? You can use this approach, but again, let me tell you, this approach is not very good. But certainly it's better than Herman single factor. If you want to, you can say, I will have used the ULMC. It's an unmeasured latent variable approach. So it's a simply Professor Gaskin's video is available on the same also. that it simply says what it meaning is. If you understand statistics, if you have attended any of my workshop earlier, see, satisfaction becomes a case of multiple regression now. If it is not available, how much incoming arrow? This one. Don't see it. It's just the error term. Only one variable from independent. This is the case. Now there are the two independent variable. For the satisfaction, whatever the variance is there, now two will be competing, satisfaction as well as CLF, common latent factor. Both will be competing. Now, if CLF is not really important, then satisfaction will have its weightage, its beta exactly same. Beta will not be changed. In the multiple regression, it only comes when they have something in common, they will share and value will be go down. If it is the case, CLF is absolutely not important, then satisfaction beta will be whatever it was earlier, exactly same. Then you say it's okay, fine. If it is changed, then you will say, well, there seems to be something. I don't know what something is, which is the factor which influence it. I have absolutely no idea. I only know that yes, something is there. Now, what you do ahead, when you admit that there is something, Professor Gaskin say here, now impute in the presence of this variable. Because it means now whatever the value of satisfaction will be computed and saved in the SPSS file, this will have the traces of this. You admit it and go ahead and say it's a limitation. I repeat once again. Because it's some higher level thing and it might be that you are not able to connect. So please see, just see the concept here. Number one, in the MLE method, what happens? From the factor, we predict the statements. This is number one. Number two, it's a case of simple regression because this is the independent variable, this is the dependent variable. And you can just see here how much variations it is explaining. So it is now explaining, if you look here, unstandardized, 59% of the variation are explained by satisfaction. 59%, the rest will go to the error term. You must know what is meant by variance explained, else you won't be able to connect. So this is the beta, 77. Now my point is, if I put any arbitrary thing, anything extra, and I put a regression here, this 0.77 should not change. Try to see it. See, I am teaching to my class, and one person come into my class. I am actually not looking at the class. I continue teaching. The person is dancing, moving some faces or doing something. I am not affected. I'm just continue teaching. The person will go away and we will conclude I am not affected by any external person because the person came, person tried to irritate me. I was not irritating. I continue my class. I am not affected by that person. Okay, makes sense. Second thing is, when I stopped my teaching, I said, why you are here? Why you go out or don't do this or this? Somebody take this person out. It means I am affected by the presence of somebody. Does this make sense? This example. If I am not affected, it means the person will do something, person will be called non-significant. The person will be out. If that is significant, it means that definitely it got my attention and I'm disturbed. So the same thing I'm doing here. What is the case here? I will say, let's put any arbitrary, okay, a notorious student who is here to trouble all the satisfaction and the loyalty. Now this is working with it, this is working with it. And now this person is trying to make this relation something like different or make some changes. Okay, let's run it, proceed, and let's see what is the result. Model fit, just a minute, not for the model, not admissible. Okay, there is one issue with even. There is another sort of problem. So let me remove this one. These are some things you should know about this. Let me change the regression weight and try to run it here. At times this becomes a very quick solution. Yeah, this is solved. Now first thing, please note, from 59%, this is 68%. Earlier it was 59%, now it is 68%. Why? Because this person, my student, is now this influenced by this also, minus 0.19. And earlier it was 0.77, this changed to the 0.8. These values are changed. Now the point is, what this method says, if there is absolutely no effect on these values, earlier they were same, now they were the same, it means this effect is useless. There is no effect. There is no third thing present. Seems very simple. Seems very simple. Post hoc, you do it, click and see. And if the result are changed, then it means this satisfaction and its relation with these statements will change in the presence of any external factor. I admit I don't know what are the factors, whether it was the mood, whether it was the situational proximity, so many factors were there. I don't know what it is. I simply know this will influence my relation. Okay, but I was looking for the relation of satisfaction to loyalty. Yeah, now what you do, impute in the presence of this. You will in the spaces file, you will find the value of CLF also. Let it be one side, weighted value to go ahead with the result. You also know, hello. You also know that these values are affected. Say it's a limitation, we can't do anything. There is something else present, we don't know what it is, but whatever the results are, let me report that results. This is one school of thought. Okay, this is called post hoc. Other people said, instead of doing this, can't we measure it? Let's measure it with something. So instead of this CLF, they said, only thing will be, we will measure it using any of the method. And these are the methods I was sharing with you yesterday. So the methods shown were something like, okay, I think not here. I should start from little back. This is the approach I am talking. These are the initial approaches which now has been rejected, but you must know it, concepts. Either you know a marker variable, directly measure it and remove its effect using the partial correlation, or take a latent variable, a separate latent variable, and use that as the marker variable for removing the effect of partial correlation, or the third one, unmeasured latent marker construct, ULMC approach. So these approaches were popular actually, so many people used. That's why this was the social desirability scale was there. And I told you actually not one, 3 scales were there. Now we should be happy there are the 3 scales. But again, a study was done by Heldon, and Heldon said, well, you know, I was really shocked to see there are the 3 scale, all are measuring the social desirability. So I assume they should be same. Okay, but he said all the 3, they are not the same. They did not show the strong convergence. It means the same variable you are measuring, it's not the same. It's something like saying, when I am checking your weight is coming something else. Kuldeep is checking it something else. And when Shraddha is checking, your weight is something else. Now, again, there's a big question mark on itself, whether it's a problem with you or whether problem with our scales. If we measure the similar thing, it should be same. How it is not the same? Why it is not the same? And this actually happens with our thermometers which we keep in our home. Everybody know, I don't know whether you noted or not, you note down your one and you go to the clinic and doctor will measure, there is always a difference of 1-2 degree. Thermometers are not state of the art like this is the case. No, thermometer will change, maybe from going from here to there, that 1 degree might change in that process itself. Similar is the case here, how to measure that. So they have given these sort of the scales, social desirability. People have given the Spanish scales, etc. Some said use this unmeasured latent method factor. That's okay. You can go ahead with these also. But now we come with something. This is the Lindell study in 2001. And if I go quickly, he talked about the marker variable. So please note down certain thing about the marker variable. Now this is a next dimension in common method biasness. This is a more scientific method we are working with. Number one, they say it's a theoretically unrelated. So marker is a variable which is a neutral one. It should not itself be a part of that. You remember yesterday I gave you an example that India has some sort of border is hot. Some border tensions are there with one of the neighboring country. So Indian soldiers are also replying to that. So what they do, they invite a people from the BBC. They say you are the neutral person. The first thing is it must be a neutral party. Only then you can make your claim. Then they will be taken along with the soldiers to the front, and whatever they will be feeling, we will get that reporting. What you felt like, what is happening, what is your point of view, and the same will be considered. See, what you are thinking, we are also thinking the same. And other than that, what then I am thinking this minus this, it means this is my this, because if anybody neutral person will go there, this is the same of the feeling. Okay, because I am just saving myself, that's why I am doing this. Plus, being a person of India, what is my real feeling, that will come out. So here the point is, one, it must be theoretically unrelated of the construct of instruct. Now instead of a BBC, if you take the Aaj Tak channel people, so they are actually more related to it, and they will not give you the correct thing. And measure it with or without the measure to define the potential effect. This is also talking about the, we will use the partial correlation to remove its effect. That will be, will say this is the real one. So they are very clear. They say we are not measuring common method biasness. Please be very, very clear about it. We are using it as a proxy. We are using it as a proxy. We are not measuring. And that was actually, this approach was very, very old, rejected later on, but a very good concept they started with. Problem here is you are using it as proxy. Proxy of what? You cannot say proxy of all. Common method biasness can be there because of respondent, because of the scale, because of the item construct, because of the situation construct. So many factors are there. This is proxy of whom? They said it is proxy of overall. The people later said, no, 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 that doesn't make sense. Proxy, it means, am I saying that we should use more than one marker variable? Maybe. Yes, you have to go for that. You have to use more than one marker variable. So marker variable can be chosen post hoc, but preferably it should be on the a priori. So the best way is to get a zero correlation. Now this is what is the justification of the same. You must write this. So I can only show you, I am, please see, I don't have a list that Shraddha, this is your variable, Kuldeep, this is your variable. No, 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 I'm not saying that. I am just saying how the people have done in their study. Look for their study, read their justification, try to think in your area. Please do not have some very unnecessary, unreasonable expectations from me. I'm a Santa Claus and I will distribute marker variable to everyone. No, I am just explaining the concept. You need to show the justification why this has a zero correlation. A priori is always a good one. Okay, then you can use one or multiple marker variable in using this. Only point is they should be similar. Now just think of what is meant by similar. If you take BBC cameraman, just like the BBC cameraman, etc., taking camera, doing 4 or 5 foreigners are there, the other side will not shoot them because they know these are the people, outsiders. They won't shoot. So they should also be into the military clothes. They should also be in the similar thing. Appearance wise, they should be similar so that the external factor will not come to know this is something else and this is the real variable. So they will feel all are the same and they will have the influence on all. So here, semantic, if it is the 5-point scale, the common method variance or the whatever variable, marker variable should also be the semantically same. It should be small number, it should be novel, it should be narrow in definition, close proximity, others. In terms of appearance, it should be same, but in terms of essence, no correlation. That is something we need to work on it. So it requires perceptual subjective response also. If your item requires a perceptual response, marker should also require the perceptual. Means if they are asking for thinking something, marker variable should also be. That's why some initial marker variables were taken like age, like your salary, like your gender. They said, no, no, no. You are measuring something like politics. Politics is not a fact, it's an opinion. So people are thinking to give answer. So marker variable should be something like that. So it should also have that comparable region, etc., same format, and everything should be the same. Now, having said this, from 2001, and they have given a process. I'm skipping the process because now it's not used. Now, this is one of the landmark paper. This is, I think, this paper who really changed this field, common method biasness, a tale of three perspectives. What happened actually from 2001, actually from 90s to 2009, there were so many papers were written. So many people have done so much. It was a mess. It was a total mess. So these Richardson, Simmering, and Sturman, they wrote a paper and they compared the a tale of three perspective. What is meant by the three? Actually, it got a lot of meaning. They said, first we will compare the three sort of the techniques. One is ULMC. ULMC it's a post hoc. You simply connect with all, popularized by Professor Gaskin, made a macro also, that plugin also. Correlation marker approach. Correlation marker approach is which is given by you take a variable and partial out its effect. 2, 3, social desirability panels, and a CFA marker approach. Now, CFA marker approach that was given by Williams, but they didn't name it such. The Richardson, etc., said there is a CFA marker approach. Okay, so three sort of approaches they have compared. UCMC, this is one post hoc. Correlation marker approach, this is post hoc also, a priori also. A priori, you have a separate variable and then remove its effect, or you can take the lowest correlation and remove the effect. And CFA marker, it's a priori. Marker is a priori variable. They defined something is there called ideal and non-ideal approach. The Richardson, etc., they defined something as they have given some do's and don'ts of marker. Number one, it should be a priori. So it should be very, very clear. Ideal variable is marker variable is a priori. So please, those who are at the process of they are just to start the data collection, please have a marker variable. It is at most important for you. That should be theoretically unrelated. Okay, and that should be similar in appearance, etc., content format wise. They called it as ideal variable. And then they defined something as the non-ideal variable. For example, respondent age, respondent gender. They are okay. They are not similar to a substantive variable. They are a priori also, but they are not in the similar to appearance, etc. So people, again, how can biasness affect your gender? If you are in very terrible mood, you will still be a boy or still be a girl. You won't change your gender when you are angry, and you don't your age also. So I don't say they are really important, but ideal marker is a good one. Now they used this approach. Three approaches they used. The first approach, no common method variation. So there was one person called Spector. He also worked a lot, wrote a number of papers, and he called a term. This is a urban legend. Quite many of you must be thinking, urban legend means, just simply you have your cup of coffee sitting in an AC room and just keep on bubbling the questions. There is common method. There is no such thing. There is absolutely no such thing. You are having your variable, your measurement is perfect. Go ahead, work with it. Well, we would like to really appreciate and adore Spector, but his approach was rejected. Non-concentric approach means same effect everywhere. Absolutely same effect on all the variable. And this is even little threatening because it says different effect on different variables, IDV, DV, etc. So three approaches are there. And for the approaches they used, if you use the ideal marker, if you use the non-ideal marker, and then in that again, they compared the when ULMC, correlation marker, and the CFA marker. Do you understand what is three? Three are the approaches, three perspective. No common method biasness, congeneric, same effect on all, whatever variable is that is equally affecting all, and congeneric means a different effect. Then if you use ideal variable using here, ideal variable here, and then in each of them, there are the three approaches they tested. They used simulation. They used a simulation. They haven't collected the data. They use simulation, and these are their results. Just to see the results quickly. ULMC is correct 41% of the time. So if for today you have collected the data, you can go ahead, but remember it is correct only 41% of the time. Correlation marker approach is still better than this, and it says 69% of the time if you have used a priori method and thought of something. Correlation CFA marker technique is correct 73% with the presence or absence, and when you used with the marker, ideal marker, it is 84% of the time it is correct. This is the best one. Comprehensive CFA marker approach. After that, all discussions were stopped. All sort of, there's sort of mesh was cleared. It was very, very clear, and it's published in the A-star journal. CFE marker technique is 84% of the time. And one more thing, if you know something about the type 1, type 2 error, maybe I'm asking too much from you. If the result is present and you say it's present, it's a good thing. If the result is absent and you say result is absent, it's a good thing. Accepting the wrong and rejecting the correct, both are the errors, type 1, type 2 errors. So CFA marker technique was the only technique which is very good at when it's not present, it will tell it's not present. Others are not able to tell. When they are not present, they might tell it is present. So this is only which yield with the type 1 as well as type 2, both errors this deals with. So this is the best one. And after 1 year after that, Williams, whose approach was this comprehensive, they said, okay, let us go for review. And this is a seminal paper. This is a wonderful, wonderful paper. I think this is one of the milestone. Certainly, I will discuss about their approach, but their review is again wonderful. They have given a very detailed review about what people are doing. And now see, this is your answer, what you are looking for. These are the studies using correlation with marker. Number 1, they said, please look, to add one more dimension, whether you are looking for structural equation modeling, whether you are looking for simple R, correlation or regression, marker can be different. The studies which used only correlation, their marker was like helped each other. I have not written the DV, IDV. It was not possible to give complete detail, but in this paper, they have given the complete detail. Arnold and Spell, they have taken marker variable as helped other employees. Large city, modernity, financial giving, success with the traditional advertisement, age, effective commitment. Now you need to look for their work and what was their reasoning, why effective or continuous commitment was not related with your substantial variables. Employee receives safety orientation, financial referent, high level of education. When there were, these are the studies who use marker variable when they use the correlation. Those who use CFA, etc., global reach, organizational citizen behavior, trusting stance, inequity, work-home conflict, social desirability, bureaucracy, tenure, satisfaction with the life, creative self-efficacy. These are the sum. I am not giving you anything that you need to use bureaucracy, etc. I ask you that please go read their work, read their reasoning, why they have, how they have shown, what are their variables, why bureaucracy is not related to that, how it was measured, and it's a marker variable, how bureaucracy was measured on the similar sort of scale. You need to do some hard work. I'm just sensitizing you that see, these are the people who have worked with it. And now I will discuss about this technique. This is a very, very objective technique. There is nothing like, your opinion thinking. It's very much simple forward. Just like if you know about the mediation process, it's a 3-step process. Likewise, we have the 3-phase process. One is we will check whether there is a common method biasness or not. First question. Second question, if it is present, is it congeneric or non-congeneric? The meaning is whether this external thing will have same effect on all the variable or different effect on the different variable. This is we will check. Third, even more important, whether the effect is there on the item or effect is there on the construct. Think over it. I asked items. I never asked construct. Construct is intangible. Construct is something you will infer to. So what I asked some questions, some statements. So what do you think? The effect will be there on items or effect will be there on the construct? If the effect is on the construct, their R will change. If effect is there on the statement, then AVE, etc. will change. Reliability will change. Hope you are able to connect me. So next we will check whether there is a effect on the correlation also or not. This is what we are going to do. In the second phase, we will go for the second phase is please tell me your updated reliability. If you say common method biasness is present and if it is affecting item or construct, please give me the corrected R and the corrected reliability. And the third thing is, don't stop here. Third phase will be, what about the sensitivity analysis? The meaning of the sensitivity analysis is, this is your simple data. If I'll go for the future data, what will be the future prediction? R will change. Do you remember there is something called 95% confidence limits of R? So what I will use, I will use those limits, and using this, I will see how much change in the R can be there. That's why the name is very apt, very comprehensive, very detailed. Now, I know some of you must be thinking, will I write thesis or will I write all of this? Because in itself, this becomes complete chapter in itself. Well, that depends. Maybe 2-3 tables you can just put to show, but you need to show it. You need to show it sooner or later. You have to commit. Otherwise, if you know, sometimes our parents, our seniors, they know many things, but they simply ignore that we don't know. Life is easy. You can also take their model and be happy, or you can decide to work on this marker variable. Okay, phase number 1 got 5 steps. 3 phases: model comparison, second is the reliability decomposition, and third one is the sensitivity analysis. 3 are the phases. First phase, 5 are the steps. First, I will use the marker variable, a priority marker variable that we have settled at the time of data collection. Now, before going ahead with data analysis, take this marker variable as just routine any other variable. So what I will do, I will take this marker variable just like any other variable. I will run the CFA. I will run the CFA. This is my step 1. Marker variable, I will check its reliability, validity, everything else I will check, and it should be okay. Remember that BBC correspondence is just assuming it's a soldier, so it will do all sort of stuff of the soldier, etc. So absolutely no difference. We will treat it as a soldier. So it will be connected with it. It will be parameters, not on everything, run it. So I run it and this thing come. Here we will work on covariance. We will not work on correlation. We will work on covariance. We will work on the regression weight, not the beta. We will work on these things. Okay, note down these. These are unstandardized estimates. That's why some of the value will be more than 1. These are not correlation. This is not beta. This is the regression coefficient. And 0.6, this 4.2, this is covariance. And this is the, how much is the, do you know, on the top of the circle, it's completely mean and variance is shown. This is the variance of this particular circle. If you are anything disconnect, please refer to my playlist on Amos once again. And particularly, there are one video of degree of freedom. Those who are advanced user are advised that you please watch this video of degree of freedom. You will able to understand better what these values are and how we will manipulate it. The second thing will be, please note down these things. Please note down this. What is this? This is the variance of the error term. What is this? This is the unstandardized regression weight. What is this? This is the covariance of marker with others. Note it down, and do note it down this 0.4 also. In my case, I have only 2 variables. You must be having 5, 6. Note down the initial covariance of all, and particularly with the marker, note it down somewhere. We will require it. Let's go to the step number 2. In the step number 2, what we will do, we will just make these things. Why so? Because do you remember what is the property of marker variable? What is the ideal marker variable? We say this is ideal. So ideal variable must be having a 0 covariance or 0 correlation with others. So make them as the 0. Okay, compulsory. How can we do that? Double click on the arrow, go to the parameter, regression weight will be 0. I will just show you that. And all other values are shown as such, which was obtained in the first step. It's called make it as fix. Fix it. Fix it means if you don't fix, it will compute. Like this one is also fixed. Na? This you have fixed. You give 1, that means it's a fixed. So give this one, just like this one is given. Give these values 0.99. Where from I got these values? From the first step. It means fix this marker variable and fix its weight with the other variable, and then run this model and note down we will always note down C-mean and the DF. Note down these 2. This will be called as my baseline model. This is what is used to compare with the rest of the model. So baseline model will be my first step, whether CMB is present or not. So I will just take the first model, the CFA model. I will note down its C-mean by DF, and I will see how much is the change here. And if the change is significant, I will just show you that. If p-value is less than 0.05, it means common method biasness is present. Else, all good news. Common method biasness is not present, or this marker variable shows common method biasness is not present. It may be present, but your marker is not adequate. That can also be a scenario. So if you are somewhere disconnected, please see once again. We are talking about the process. This is a 5-6 method process. Step number 1, we will take the marker variable as good as any other marker variable. We'll check its reliability, validity, something, everything else. You check it. Don't be that stringent on the reliability, validity. If it's nearly okay, then consider it as the okay. Note down some values. These values noted down, because in the next step we will make it as fix. Remember, here also you have made it fix. This one value you have given before starting, but other values will be calculated by software. That's why you need to know the concept of degree of freedom for any single thing. Well, if I'll explain here, it will be too much, but basically you have something like variance, covariance, and what the Amos compute for any circle, whether this or this. Compulsory, it will compute mean and the sigma square. For all the arrow, it will compute value. This value will be computed, value computed. When number of your computations is equal to number of items in the variance covariance matrix, when they are same, degree of freedom is 0. If it is less, then model cannot be run. You have to put some extra. We call it as, you know it by the name of unidentification problem. Well, simply notice this. Go to the step number 2, fix it, restrict it. Okay, with this 0. Why 0? Because we believe our marker variable as ideal one. Compulsory we made it 0. Now these will vary, their values will change, not on the mean value. Comparison of the CFA and the baseline will tell whether there is any sort of common method biasness or not. If biasness is present, go ahead. We will check from this one marker variable, and remember this all is constrained. What we will do, we will put an arrow on all of these. Here I have the 8 such items. If you got 5 such things, so, and everyone got 3 or 5, so many arrows will be there. And put a double click and put a similar number on all of them. On every arrow, make their regression weight as similar. Write any number, same number. You can write X, you can write Y. I have written write anything. It means I have restricted all of their values will be same, exactly same. This one is called as constraint. Constraint means what I'm checking. I'm checking whether it is non-congeneric, whether the effect of marker is same effect on all. This is what I am checking. Whether the effect is same or not, this is what I am checking. And naturally in the next one, this will be free to vary. So they might have the different effect. Marker variable might have different effect on all different things. A comparison of model C and U will tell us whether the effect is congeneric or non-congeneric. Okay, this will check. And finally, we will restrict. What we will restrict? We will restrict this value. Remember, what is this value? This value came from the first step. In the first step, in the CFA, when we worked with, we checked what is the relation between this. We constrained this relation also. And now we will check. This is called restricted model. If restricted, this will basically tell whether the influence is there only on the item level or it is there on this level. If it is on this level, then the effect will be changed. If effect is on this level, then it's so the 3-step process here that we will do. These are the 3 things we will do: baseline and the model. They will check 3-step processes. Step number 1, we will simply see whether the impact is there or not. So step number 1 will be check whether there is an impact of a variable or not. If present, then only we go with the step number 2. What sort of effect? Congeneric or non-congeneric? And third case, irrespective of this, third step will be, third comparison will be model U, model R, whether there is an effect on the correlation among construct or it's only item wise construct. That is what we will check. We'll just do a case here and I will show you how to do it. After that, we will go for the reliability decomposition, and there are certain formula, and we will work on how much of the reliability is because of the marker variable. So Ramni ma'am, there's an answer for you. She asked before this session, why actually what we are going for common method biasness. Just like Spectre said, you are just, passing your time and doing this thing. But Ramani ma'am, please see, 16% of the reliability is because of the common method biasness. That must be improved. Actual reliability is 0.6 and reported is 0.8. That's why I am more interested in how you measure and how to remove the effect. That's very, very important. And look for the sensitivity analysis. The meaning of the sensitivity analysis is, if I go for the future, go for the bootstrapping, check that if in the future 95% confidence limits will tell values can change, even if we got very high values in the next samples, what will be the effect, how they will be changed. That's called the sensitivity analysis. So this will be what I will show you with you. And after that, there was another paper. They said something more about the marker variable. Now there is a 6-step process. Let me just quickly go to the 6-step process given by Marcia. This is the latest one which we recommend today. How to choose a marker variable. This is a 6-step process. Just look for the 6-step process, as please ensure that you mention these steps in your work. Best practices are: number 1, name the variable and describe the marker. Why it's a marker variable, describe it. You name it, give a proper name. Please don't shy. Please use it. Don't shy in saying that yes, there can be something else, to at least measuring it, removing its effect, controlling the effect. Think of the response scale format, other measurement properties, and make it similar to that of the substantive variable. If you are using 7-point scale, try to take it on the 7-point scale. My approach is, yesterday somebody asked a question whether it will be nominal, ordinal, scale, or what. My understanding is, please look for, we take from the respondent 2 things, either information or opinion. Information is taken on the MCQ, on the binary. Okay, if I'm noting down your gender, I don't think common method biasness will affect that. Common method biasness will not have any effect on where from you are pursuing your PhD or where you are employed. It will have no effect. Okay, it will be same answer. So information, in my opinion, is not that much influence, but opinion is 100% influence from the external variable. So my perspective here is that it's basically for the opinion when you will work with the common method biasness, constructs, etc. And since you are measuring it on 5.7-point scale, so take the marker variable also on the very similar to those. In second, report the correlation matrix. Before going ahead, show it. Now, why correlation matrix? Because correlation matrix will give you the true picture. If marker variable is automatically very highly correlated with IDV, and you said there should not be correlation, isn't it? So that automatically puts a check on you. Show the correlation. Marker variable should be having very low correlation or 0 correlation with all substantive variable. What are substantive variable? Dependent, independent, control variable, the main variable about whom the study is conducted. They are substantive variable. They should not be correlated. The third one, identify the marker technique. Well, CFA, comprehensive CFA marker technique is the best one. You should go ahead with that. And describe why marker variable is not expected to have any relationship with the others. Please write some paragraph. If you can present any sort of citation, that's fantastic. If there is any theoretical based argument, that's fantastic. You must write something about it. You cannot simply write, I have taken and that's it. No, you must write why part. Then use this. Author should detail the why marker was chosen and indicate what type of bias. It means now we are talking about there can be more than one marker variable. Discuss the theoretical content, susceptibility, etc. Why it must choose it a priori. Post hoc is not accepted these days. And there can be actually for different, you can think of, because of the mood, I have taken this variable. Because mood is bad, then I ask this question, this will be also affected by the mood. But this particular variable is not related with DV/IDV. Since it was the situation, I asked a few questions which are not related with DV/IDV, but they can be actually influenced by the situation you are in. So it means I am taking for the different sort of the sources, I may take different sort of the marker variable. It's perfectly okay. So these are the 6 practices which are given, and now I will go ahead with working with the Amos to show you how actually we work with how actually we commence ahead with it. But before that, if any questions are there, you are most welcome. I will request organizers to please enable the chat box. If any questions are there, I know there will be lot of questions. Okay. So welcome you once again. In this session, I will start with the working on the common method biasness with Amos first, and then with the smart PLS method. Please note, when I say comprehensive CFA marker approach, this is available only for Amos. The other approach is not comprehensive marker approach. That's a different approach given by Chin. So this is given by William, 2010. Approach name is comprehensive CFA marker variable. It calls for 2-3 things. There is a concept of ideal marker. The ideal marker is one that is a priori, which you measure at the time of data collection. You must have a justification that why it is not related with the substantial variables like DV, IDV, control variable. But it must be similar in appearance that of the DV, IDV. So if it's a 5-point scale, marker variable should be 5-point scale. In case you have some variable on 5 point, 7 point, on 7 point, you can decide it can be like any one of them, but not very distinct, like any one of them, this will do. Then the third thing is you must also write why you think this particular variable will capture what sort of bias, because bias are related with 3-4. One, there is a biasness may come on the part of respondent, biasness may come on the part of scale, biasness may come on the part of context, item context or situation. So you must explicitly tell the bias, whatever you have taken, whether it is looking for which particular source. So it means there can be more than one method bias or marker variable for method bias. That is also okay. Rather, that is also advisable. So we assume that we have a variable, we have a file called demo, in which, or marker.scav is the name of the file. That's a subset of demo. Only 2 variables I have taken, satisfaction and loyalty. And third I have taken as the marker variable. In my data file, the marker variable is simply about, it's a dummy data. That's not a real data. So it's a dummy data, just for demonstrating how part. I'm not touching the why part, why this is should be there. So I will request the organizers to disable the chat. I will take the questions later on. So let's start from here. I'm starting afresh. This is the first CFA model. I assume you know about the CFA in Amos, confirmative factor analysis. A circle is called as construct. These are the statements. The arrow will go from construct to statement. So in the first phase, we will use marker variable as any other routine variable. We'll go for reliability and validity. I'm using plugin provided by Professor Gaskin. So master validity, it will check. If you don't have a plugin, you can use stat tool package or you can compute manually. CR, AVE, MSV, there is no red, so it says no validity concern. It's a good news. Note down the model fit values, and along with the model fit value, CFI, GFI, some of the indicators you note. And please mind the indicators CFI, GFI, etc. The higher the value, the better they are. RMR, RMSCA, the lower, the better they are. CMIN, the lower, the better it is. So first value is 94, and I am noting it down in Excel file, 94. Degree of freedom is 41, CFI 904, GFI 856. Let me write here as RMR also. So that is 0.087. So this is the first one, the routine CFA. In the second one, what we need to do? In the second one, we'll come to this and see the output. From the output, we have to note down these values. So the values which are associated with the marker variable, note down these values. So it's 0.99, 0.96, etc. So I advise you to watch a video on degree of freedom Degree of freedom basically talks about that whenever you have any circle, for any circle in Amos, its mean and intercept will be calculated. Now in the error term, mean is always 0. So that part is taken away. So it's a variance. For any arrow, it's always the standardized weight is calculated. On the two-sided arrow, it's a covariance and correlation. If I click on the standardized, it's correlation. And if I click on unstandardized, it's covariance. We are talking all in terms of covariance. If you remember, for the routine CFA, we always work with the standardized estimate. In standardized estimate, this one is dependent variable, this is independent, so this becomes a beta. And the beta is equal to R in simple regression. So simply its square will be the R square. Now we are working on the unstandardized. So these are regression coefficient, hence the value can be more than 1 also. That's perfectly okay. Regression coefficient, unstandardized regression coefficient can be more than 1. Now we'll go for the baseline model. In the baseline model, two things are done. The first thing, retain the values from the first one. So simply double click on this, you will get parameter, and in the parameter variance, provide the variance, the thing which we have noted from here. 0.223544, I have kept this, 0.22, etc. These values are 1, 0.99, 1.16. Please note, I am taking these values from here. That's it. And second thing is, this is first part. Second part is draw a line from this common latent factor to, or let's call it as marker variable, from marker variable to all the dependent, independent, all sort of variables. So you know how many constructs you have. There should be an arrow for all, and double click on every arrow and make a regression weight of 0. Double click on every arrow and make a regression of 0. In my case, I got 2 variable. You might be having 5, 6, 10 variable. It doesn't matter. In Amos, we make the entire diagram on this canvas. But even if you go out of the canvas, nothing will happen. The things will move. Even if you take it outside this, okay, just a minute. Not able to take, okay, because of this comment. Okay, if you take it outside, it will still run. There is absolutely no problem. So two things I have done. Marker variable I have restricted. Values are made as the fix. Now there will be no calculation done by Amos in case of marker variable. Reason being, its error its term is calculated, its variance is calculated, its values, all values are calculated. Now only thing is, and its effect, marker's effect on all is constrained to be 0. So this is a concept called idle marker variable. Marker variable is not related with any other variable, and it has initially assumed no effect. Note down the values here, run. Now I will not check the validated reliability again and again. I will work only on the model fit. In the model fit, value comes out 120.921. So let me note it down, 120.921. Degree of freedom has increased to 49. CFI value is 869, GFI 840. RMSCA value is, check it, RMCA value here, 122. And RMR value is 0.229. Increase a lot. RMSCA, the lower the values, the better they are. So here you can say model is actually going down. CFI, GFI, higher, better they are. You are looking at value is actually deteriorating. CMIN. Now you can just simply compare the CMIN, because we need to compare the CMIN by DF. Degree of freedom is also changing, and that is also increasing. CMIN by DF. It should go down. It should go down. Now we'll check whether how much is increase. There are some change. For example, in baseline, the change is only 96. So how much is the difference? So there are the two methods for that. One method, you refer to the chi-square value and just see how much is the change in that. Let me calculate here. So this minus this, and likewise second one. For the degree of freedom 8, you can refer to table value of 8. What is the maximum permissible difference? Whether your difference is more or less than that. Now, if somebody is interested in chi-square, so with the degree of freedom and the chi-square value, I always ask my student that you must remember some values. It's something like 4, 6, 8, 10, 11, 12. The values are like this. Like this value is 3.84, for 2 it is 5.99, for 3 it is 7.84, for 4th it's something like 10. So you can look at from the at the back of any book, these values are given. Or the other method is, we can simply in Excel, chi inverse RT. This is the function. So it says on one probability, we always work on alpha of 0.5, and degree of freedom I will give from here. So it will give me those values. And you check it, the values are very, very close to what I told you, 7, 8, 9, 10. So it means we can assume up to the variation of 15 by chance. The variations of this you can see from the table value also. If you are not very comfortable with Excel, absolutely no worry. You can just see these values from your table that's given at the end of any book of statistics or research. This value, table value, I always call it as, this is the maximum difference which is permitted because of by chance. By chance, there can be a variation of 15. We have a variation of 26. It's not by chance, and it confirms the presence of method biasness. So I will say here, the first one will be, sorry, here I will say method bias or CMB, common method biasness present. Don't worry, it's not such a shame or bad thing. It's a simply, we will, if it is present, we will work on it. We will modify it or check it out. Now model C, constraint. The meaning of the word constraint, please see what I'm constraining. Let me save it and go for the model C. In the model C, I have just made one changes. The marker variable to all the values, initially they were 0. I double clicked on that and I put any number. Alphabet, it's better you put an alphabet, X, Y, Z, A, B, C, anything, but it should be same. It means now when this will compute, first thing, let me show you, it will be computed. Value of A will be computed. And now see, the value is 0.44 in the cases. For simply a number means you are instructing a mouse. You can calculate, only thing is this value should be same for all the arrows. What it means, we are saying this is the same effect of marker variable on all variable. What is so when we put the same number, same alphabet, it means we are asking a mouse that please calculate the value, and the value will be same for all the arrows. What it means? It means the effect of marker variable on all of them we assume to be same. What is the technical name for that? This is called non-congeneric. Non-congeneric effect is there. So I'm checking whether there is a non-congeneric effect. This I will check. So let me run it. I will note down the model values. And now model values should improve 91.16. So let me note it down, 91.16. Is it 16? Yeah. Degree of freedom is 47. Okay. And we can see how much it's 1.9, certainly improved. Not only improved from the baseline, also improved from the CFA. CFI values, etc. 0.92. GFI, it's 0.852. RMR, 0.103. And RMSCA, it becomes something like 0.097. Okay. This is assuming, now Ramani ma'am, please note, we will do this method only and only, we will go for the method C, model C, only when this is present. If it is absent, the P value is greater than 0.05, you will say no method variation present, or a better will be saying my marker variable was not able to capture. Okay, you cannot say no method variation present, only thing your proxy was not able to identify, but you have given justification why you think proxy or that marker variable was good, so that's okay. You have attempted, from your honest opinion is marker is not, method variations are not present. If it is present, only then you will go ahead with this one and this one also, both. These are two independent steps. First, let's go for this. It says, having established that method variations are present, the point here is whether its effect is same or all, or it is different for all. Assuming it is same for all, that is called as C means constant, it is same, non-congeneric. Non-congeneric means you say effect is same on all, and U means unrestricted, congeneric. The meaning of the congeneric is right from the birth, there can be different effect for the different variables. How to do that? Non-congeneric, we have restricted it, we noted the value. Let's go for model U. U for unrestricted, C for constant. What we need to do, in this case, what we'll do, we will remove the value of the A. So it will be like this. Rest of the thing, remember, marker variable, it's the same, effect, everything. These are 0. Only thing is I have removed these values. Now all of the arrows can have any value they can have. Let's run it and see whether the values are same or different. You can see the values are 0.5, 14, 33, 85. Can you see the effect is different on almost similar for satisfaction 22, 20, 1923, almost similar, but here can you see it's very, very different 8535. Okay, so note down the values here, values of a model fit, etc. So model fit value is 69.593, 69.593. Degree of freedom is 40. The value comes at 1.7. I can see an improvement. We'll see whether it's a statistical significant. CFI value comes out as 0.946. That also seems to be improved. GFI is 885, again improved. RMR 0.06, certainly improved from 10% to 6%. RMA SCA value that improved to 0.086, also improved. Is it significant improvement? Let's check it out. Is equal to the difference of the two. Now, while using the difference, I will advise you always to take higher value minus lower value. The reason for the same is when you use this function chi-sqrt, if there is any negative value, it won't work. So it has to be the positive value alone. So check it out. P value is 0.003. P value less than 0.05 means it's the difference. What is the null hypothesis? There is no improvement, though both C-mean values are same. What is the null hypothesis rule? P value less than 0.05 means null hypothesis rejected. Rejected means we can say there is a significant improvement. Then hence we will assume we have a congeneric common method biasness as compared to it. Please see so far. CFA is the routine. Baseline, I have just restricted marker variable in two sense. What are the two sense? The first is I have put its value with others in the baseline. Number one, I have taken from the initial model. Here, I note down these points 2, 2, 3, etc. 1, 0, this. All I have noted down and we put it here. In the baseline, actually, instead of 1, I should make it as 0.47 because this 1 was created by Professor Gaskin's plugin. It should be 47. Where from I get this value? This value I get from the initial model. Initial model, if you run it, it's 0.47. When I use that plugin converted it to 1. It should be this value. So you run it. After running it, get the values and check whether there is a significant improvement or not. If it says, yes, there is a significant improvement, significant difference, then only you will go for the model C. Now, our next question is, having established that common method biasness is present, the question here is that whether it's non-congeneric or congeneric, whether its effect is same on all or its effect is different on all. That's why you can see we are talking only the effect of marker variable on items, not the construct. Hence, we will not be worried about second order, third order. Only items are polluted by this marker variable. Null hypothesis I have noted for C, I have noted for U. So what's the basic difference between C and U? First, C, what is the difference between baseline and model C? In the baseline, from marker variable to all variable, there were the arrow. On that, I have put 0. In model C, I have put same value, any alphabet, so that the value will be same. In U, I have removed that alphabet and then it means they are all varying, they are all changing. Now look at the C-mean. Null hypothesis is there is no significant difference. When null hypothesis is rejected, it means there is a significant improvement. It means model U is better. If the p value is greater than 0.05, we will say that it is non-congeneric and doesn't matter. There is no significant improvement. They are almost the same. We'll say non-congeneric. Now, in this case, we say there is a congeneric effect is present. This is the how to change. Simply look at their value difference, look at the degree of freedom, and what is the function we will use? We will use chi_sq.dist.rt. This is in Excel. There's a function, or you can simply refer to your table, statistical table. Look the degree of freedom when it is 7. What is the value? If your calculated value is greater than that table value, null hypothesis is rejected, and null hypothesis is there is no improvement. Both values are same. So that's been rejected. Now we'll come to the last next phase, not the last, next phase, fifth point. The fifth point say whether there is an effect on item or on construct also. Now we are checking whether construct is also biased, whether the effect is on construct. How to check that? We will say only in this U model, we will make one change. And what is the change? See, initially I said satisfaction to loyalty can be anything. If you check it here, the value is 0.35. It can have any value, because on the basis of entire calculation, all the values, etc., all are calculated on the basis of, so that the error terms should be minimized. What is this method? MLE, maximum likelihood estimation. Calculate all the values, whether these values, their variance are, etc. Calculate all the value so that my actual value and my predicted value will be almost similar, or I can predict it as maximum as possible, or error term as low as positive. Now instead of that, I will say, let me see, will there be any effect on all my model fit if I'll keep this one also as the constant? Here I am saying there is an effect of marker on all, right? Now, if you look at the first one, initial model, what was the relation between satisfaction and this? The relation was of the order of 0.4. 0.4. Now I'm talking about the construct. I am no longer talking about the items. I have established that marker variable has an effect, and that effect is very different for the all different variables. Now I'm concerned about the construct, 0 order construct only, not about the second or the third order, 0 order construct. So what was the initial in the step 1? What was the relation? The relation initially between the two, it was unstandardized covariance, it was 0.4. So what I will do, I will come to this one, model R. Model R, only one difference I will make in model U. This was the model U, which I have just worked on. Double click on this and put this value as 0.4. Put this value as 0.4. How do I know this is 0.4? I have taken it from the initial model, CFA. In case, assume you have the number of variables, 5, 6, 7. So you have to make the covariance. What was there in the first model? Same what was there in the first one. If you say, I have some second order, third order. Please remember, I always say, you never decide whether there will be second order, third order. When there is a very high R, then second order is a way out of it. Then second order is a solution for that. So you never say it's a second order. We always work on the constructs. Remember, at the time of data collection, you ask certain statements. Respondent is not concerned whether you will call them second order, third order, or whatever. Respondent answer the statements. So simply make a double click on that, and in the parameter give the covariance as 0.4 and run it once again. And check it out for model fit value. It's become 69.989. So let me write there 69.989. Actually, if you look at the C-mean value, it's deteriorating. Value is increasing. Model fit value is 41. It's a little bit improved, very little improvement. So let me check whether there is a significant improvement. This minus this, and degree of freedom 1. So for degree of freedom 1, chi-square value is 3.84. So let's check it out. This value and with degree of freedom 1, P value is 0.52. 0.52 means greater than 0.05, no difference. It means, what is the conclusion here? These are my conclusions, or maybe you would like to enter only this table. You can even remove this GFI, CFI, etc. This is sort of the table which we should report. Now, yesterday somebody was asking, will we write complete procedures? Even if you write only this, that we use comprehensive CFA marker approach, and this is my conclusion. CMP present, here we say that different effect, and here you say effect, no effect on construct. No effect on construct. Comparison of CFA and baseline, whether it is present or not. Comparison of C and U will tell whether there is a different effect or it is the same effect on all of the variable. Different effect on items. Checking of this effect is there only on the items or there is on construct also. If there is an improvement, it means what we have done, we have worked on the construct also, restricted the construct. Now we are saying no effect is there only on the item, not there on the construct. Okay, so here we established common method biasness is present, and that is different for the different items, and it is only affecting the items, not the construct. Part 1 is complete. So part 1 is complete. I have talked about this common method, this CFA method. Phase 1 is complete. Baseline, the only thing is you make these as 0 and put an arrow, which I have not shown here, put an arrow and put 0 on that. The next one, on the arrow put A, constraint. Unconstrained, don't put anything. Only check out for this variable. This should be made same as taken by the first one. So this is phase 1 is complete, and these are the 3 things. The table you should report baseline versus model C to check whether there is an effect of marker on loading. What we are checking, no effect, common method biasness present or absent. P value less than 0.05 means present. Model C versus U, whether the effect is same or different. P less than means it is different, it is all are different, or otherwise it is same. U versus R. Now in case some people will ask that whether we should compare C versus R or U versus R. See, here it comes they are different, then compare U and R. If it comes they are the same, even then you should take U. Okay, but that says C and U there is no difference, you can take any one of them. Statistics says no difference. If the p value is greater than 0.05, you can take any one, either C or R, because statistically they are not different. However, if they are different, then you should always take U and R. It will check whether it is only about the constructs or about items, what it will check. Second thing, we will go for reliability phase 2, reliability decomposition. Now, coming to Ramani ma'am's question, having said that there is a common method biasness and that is affecting. So please note how we commence ahead. There is a file, I usually give it in my workshops. The file is calculating the, let me open the file once. So in the SAM folder, some of you might recognize this, manual calculation of AVE and CR. Okay, so you put the values here. We generally work like this. Take the values of standardized beta for any variable. For example, I want to check for the loyalty. So these are the 4 things. Those who know about this Amos, hope they can make sense. It will make sense to them. So we note down these values, 4 values. We copy and paste it here, and it gives us value of AVE and CR. This is the value of AVE and the CR. We know how to calculate that AVE, CR. These are for convergent validity. Now we need to go one step ahead of it. And what is that? We need to work with a different one. And this time we will include this bias one. Let me show you what I'm saying. So I have made an improved table. In the improved table, it's the same you will put here, but here there is a scope for providing the method loading also. How to check whether there is a changes in reliability or not. Let me work on the loyalty part. See it once again. Let me remove all of them. Look at this one. Last model I'm checking. So I should go with the model U because that's the last model, because model S there is no improvement. I will go with this model. Arrows are there, no restriction, nothing. how to first, it's important to see which one will work. Here we said that CFA baseline, and there is a difference between these two, CMB present. Model C and U, there is a difference, so we will go with model U because there is a significant improvement. U and R, there is no improvement, so we will go with U. If there is an improvement, we will go with model R. So last correct model, whatever you find, like in this case, I find model U because my conclusion is CMB present and there is a different effect on different items. So that's why we will go with model U. Okay, go ahead with model U, run it once again, or if it's already there, just take the output. This time I'm taking the beta, standardized regression weight. Standardized regression weight. Copy this table, take it to Excel. Look at it. Now, those who know about this, they know these are the beta. And since beta is equal to R, these values are used for finding out the, you put these things here, it's not allowing. Okay, you put these values here and you get the value of AVE and the R. R value is 0.863 and AV is 0.6. This is good. Composite reliability, etc. Now this time we will say, just take care of one more thing. The satisfaction 1 is not only affected by, just see, satisfaction 1 is not only affected by the satisfaction, it also has some effect of marker variable also. Check it out. Do we have the effect of marker variable also on the satisfaction? And we admitted there is a marker variable is present. So what I will do, I will take these values also. So it means we need to calculate it construct by construct. Earlier, we used to calculate this for one construct. We calculate convergent validity AVE R for per construct. Now what we will do, we will take this marker variable to that construct, the values, copy that and paste these values here. And now you will get, this is the corrected value, or this is the 0.032 out of it is basically because of the method biasness. What you need to do, check it once again. First, you should know how we go ahead with, generally we work with. So we work with this one. We take the value, look at the R. In the R, we take the value of standardized regression weight. If I do it manually, I will say that click here, go to the unstandardized and see their effect. 0.75708187. These are the 4 values which I am looking for. These are the 4 values which are required for computing the convergent validity. These are the 4 things. Now what I am asking you, I am saying other than the 4, what about these 16, 13, 12, 28? These are the effect on the satisfaction because of the marker variable, because of the common method biasness. So other than these, you will take these also into the formula, and I have made a file for that. So this is the file which is available in the video. So it is, I think, Common Method Biasness 13 number video is there. You just see comprehensive CFA marker approach. I have given this file sufficiently large with the, you can have in one construct up to 30, though it's never advisable, but I have made a large file. And now what you will do, it will compute both. AV is the same, or if you don't report common method biasness, you will say 0.8, but because of method biasness, it's 0.03. So how to report it? We will say this is called reliability decomposition. The meaning of that, these are the formulas given. So total reliability, if you go for simple, substantial reliability is 0.819. If you don't consider method biasness, you will report 0.875. Now you say, no, it's 0.819. And how much out of the total? 0.03 divided by this 3% is reliability change because of method biasness. Okay, now I will report always 0.819. So hope this will answer a number of your queries. You should not go again for data collection, because again, if you go for data collection, again method biasness will be there. It's not a shame. It's not a bad thing. There is a procedure to tell what is the correct R, what is the correct reliability. We are working on that. So you may say 3% is negligible. Yeah, I agree with you. So, but let's check for the loyalty. In case of loyalty, these are the values 7 to 8, etc. Let me copy and paste in this table. So These are values. Well, there is a one value 0.08485. This is putting some concern. I should remove actually this beta 4. Values are very, very less. And now check for what is the effect of marker variable on loyalty. Effect of marker on loyalty. These values. Copy and paste it here. Now these values are coming 0.697. So if I don't report, it will be 0.83. Now it's 0.697 substantial reliability, and marker is 0.13. How much is 16%? So if you see, basically there is only this one beta 4. Can you see method biasness? This value should be as low as possible. 5.4 is a very large number. Because of this actually your culprit is this fourth statement. You should remove the fourth statement having the value of 0.469. That is actually most affected by the common method biasness. We can actually find where is the real trouble. Look, these values should be high as possible. They should be as low as possible. Any value which is substantially high with the others actually making all sort of the problem here. It is making probability in AVE also because it's very, very less. So this is phase number 2, reliability decomposition. It's better you say that if I don't take method biasness, my answer will be 0.8783, but actually it's still above threshold. 0.869 is okay, very near to 0.7, but it's okay. But you have removed the effect of method biasness. That's a good thing. So phase 2 is over here. Phase 1 checked whether reliability. Now again check. If the method says, if the procedure says there is a common method biasness, then only we will go for this method, reliability. Because this says what is the improvement in the reliability, what is the correct reliability, having acknowledged that there is a method biasness. When you say there is no method biasness, why you will go for phase 2? It will not be there. You will not go for the phase number 2. Then coming to the phase number 3. Phase number 3 talks about the sensitivity analysis. What this says. Let me just before that, let me ask you a quick question. A quick question is, let me run a file. Oh, is there any file called car sales or something? Or let me open this. There is something you should know about the regression. I just want to check whether you know about that. Analyze regression, linear regression, MPG depends on horsepower. In the statistics, I click on confidence limits. Now I want you to look at this table. Copy. I'm taking it to Excel. Here it won't allow. Check it out. Now please look. My dependent variable is MPG, miles per gallon. That is how much is the fuel efficiency of your vehicle. Just like in India, we say kilometer per liter. In US, they say miles per gallon. So if I'll write its equation, it will be MPG is equal to 31.813 minus 0.043 into horsepower. Okay. Now my question to you is, if I'll increase my sample size, remember you worked on a particular sample here, will it always be 31? Are you sure about it? Or it can be low or high? Your answer will be, well, it can be as low as 30, it can be as high as 33. Please remember, in statistics, wherever you find 95% confidence limits, always think in terms of the future prediction. If I collect more data, will it always be 31 point for this? Will unstandardized coefficient will always be 0.043? We will say no, it can be as low as 0.05, minus 0.05. It can be as high as minus 0.03. It will vary in this range, provided all the data is normally distributed. Provided there is no outliers, we assume the data should be within this range. This particular thing I am going to use in the last sensitivity analysis. Just see what is the meaning of the sensitivity analysis. In the sensitivity analysis, I will ask R in the model U. Model U is the last model, my correct model. I will come to the R. I will go to analysis property, bootstrap. Check it out. My last correct model is U. which told me method biasness present, and that is unequal. That's a different. Go to the analysis properties, B7, go to the bootstrapping, perform bootstrapping up to 2000 and go for the up to 95%. Okay, those who know how to work on the mediation, etc. Remember that in the bootstrapping, we go ahead with that. Click and run. Now in the output, you will find, please see here, estimate, bootstrap, estimate, etc. And that is deactivated. Once you click on the estimate, scalar, regression weight, now it's get activated. Please see it again. If you click on estimate, click on the model fit. That means this say it's same for the entire model fit is not different for this. Regression weight is not, yeah, that's a different. So when you come to this standardized regression weight, this will be activated. If you are somewhere else like notes for the model, deactivated, you can't click on that because notes for the model is same for the entire model. Estimates, scalar, come to the standardized regression weight. So now my point was, if I look the effect of marker on satisfaction 2, it's 0.204. 0.204. My question is, if I take further sample, will it be 0.204? Will it change? Just like the regression I have just done. Click on the bootstrap confidence and confidence. Some new you will get. Let me copy and take it to any Excel file or here. Please see, I was saying marker variable to satisfaction. Earlier it was 0.2. If I take some more samples and normality is assumed, so it can be as low as minus 0.011. It can be as high as 0.471. You understand it? It can be as low as these values. It can be as high as 0.47, 397, 372, etc. This can be this much high. My point is, what if it is this much high? Will it still be there, or my reliability, validity, my R will change? I doubt. So this is my last model now in MOS. In the last model, I will go with model S. What is my model S? In the model S, what was model U actually? You tell me. Model U was marker variable can have any effect on this. Now I know the effect can be, if I even go for future prediction, the effect of marker on satisfaction 2 can be as low as 0.99, as high as 0.471. So let me make it to the highest possible. All the values, I will double click, like marker to satisfaction 1. What is the highest value possible? It is 0.419. Let me put it as 0.419. So just check it out. I have put it as 0.419. Marker variable to satisfaction 2. I put it as, look, this is 0.471. What is 0.471? It says that if you go with the successive samples, there can be effect of marker on satisfaction 2 as high as 0.471. Let me take that. And let me take all the highest effect in all. Right? And this time, this is free to take any value. And let me run it. Now what we will do, we will try to find out the value of R. This is what is the sensitivity analysis. Sensitivity analysis means I will just note down the value of R in the initial model, baseline model, model C, model U, model R, and finally model S, and see if there is a drastic change or not. So here I get, well, yes, there are some changes. Let me show you there. Shall I show you from the start? This was initial model. Let me run and note the value of R, 0.7. Now I'm taking standardized estimate, 0.7. Baseline model, two things were there in the baseline model. Marker variable is restricted, and from the marker variable, everywhere else there is an effect, and the effect is constrained to be 0. When I run it, what is the value? Value is 0.7. Let me note it down. It is again 0.7. Let me go to model C. Model C, constrained the effect of marker on all of them with a particular number. So this is the constraint, fixed is constraint. Now when we run it, what is the value? R comes out as 0.68. So let me note it down, 0.68. What is model U? Model U was, these are free to have any value, no restriction, neither on this, neither on this. Run it. What is this value? This value comes out as 0.69. I have noted 0.69. Model R, there was a restriction on this. Model R was checking whether effect is there on item or effect is there on this one. So when I run it, well, that is 0.71. And model S means S for sensitivity analysis. What I have done in the sensitivity analysis, I have deliberately taken it to the extent possible. You might take one with the all lowest value also. That's again okay. Check the sensitivity on both the side. I have shown you only one side. You can go ahead with that side also. And when I run it, the value comes 0.69. So now you can say this is the phase 3. That sensitivity analysis shown me that yes, there is a common method biasness, and there is an effect also. To loyalty, there is a greater effect as compared to the satisfaction. But when we go for the sensitive analysis, there is just some sort of relief. There is not drastic change in R. There will be change, but they are very minute. Obviously, I'm not using any statistical test for them, but you will say there are the minute changes apparently. So this concludes our comprehensive CFA marker approach. You can see the paper of Williams, where they have shown one example and how the output is to be written, what sort of tables to be reported, etc. I tried to explain it, but I know until unless you will do it, it won't be clear. Second thing, it might be that you got a very, very complex model. So even in the complex model, let me tell you the very first thing, if you are working with the Amos never says start with the mediation, moderation, second order. No. Amos says first order construct. First order means check the reliability validity of all the construct. It means please look for in the data collection, you collect data about a construct, one construct. So you need to put in the Amos all sort of construct. If I'll show you any construct in a very, very complex model, let me see if I have some data there. So maybe I have the data. Let me see. Oh, these are all very, very small one. Just give me a moment. Yes, this is the example discussed by Professor Gaskin, and there are playfulness, information acquisition, a typical use, etc. 7 variables are there and getting many, many statements. Okay. Now in this, let's assume you are checking a marker variable is also here. So certainly it's going to be a mashup. There are some dependent variables, some are independent variables, some are mediators. Okay, moderators we don't take in this form. Now what we'll do, we will put one and we'll connect to all of them. So if I'll say here, artificial one, if I'll take, let's assume for a moment, this comp is my sort of common method biasness, or it's a marker variable. How we'll go ahead? First will be as such. You remember what is this called? This is called first order CFA. You check the reliability validity of all, irrespective of whether they are dependent, independent. You connect everyone with everyone. So take marker variable as just like any other. Go to the plugin, master validity, check for the reliability validity of all of the construct. Here I am assuming for a moment that this comp is actually a marker variable, not a plugin. Okay, you need to check it with the Professor Gaskin file or manually. What we'll do next, after noting the values of this for marker variable, I will constrain it. I will put from this comp a value to all of these. Let me see whether this will work. Plugin, common latent connector. I think I need to first, maybe these arrows I need to remove. But you need to connect from comp to every single one. Okay, this is, yeah. Professor Gaskin has really made life very simple. Otherwise you need to, but again, one work is required. Now this is my baseline model, but 3 things in the changes. If I double click on every single arrow and put a baseline like regression weight of 0, this will become my baseline model. I will check the CFA with the baseline to check whether the effect of common method biasness is there or not. Step number 1. Then I will click, if it is present, if common method variation present, I will click on every single arrow. I will put it as A or X, the same to all. That is called constraint. In the next one, I will double click on all and I will remove it so that any value can have any arrow can have any value, that is unconstrained. Check the constraint and unconstrained. When you put the values as the same, it means you are assuming there is a same effect of marker variable on all of them. That will be called as non-congeneric. Same effect of marker on all. And when we remove this value A, it means now every arrow can have a different value. This is called congeneric. If there is a significant difference, then you will go with the congeneric, else it's non-congeneric. Next, go ahead. Look at the original value. Go to the first one and check out playfulness, upper typical, what was there are, and covariance actually, and double click on the arrow and restrict all to their original value. That was in the initial. And then run it. In the entire process, this is constrained. Marker is constrained with the value, error, etc. That will be model R to check whether the relation, the effect is there only on the items or only between the construct also. That is the model R. Once you are settled, like if it says no common method biasness, game over, you say proceed with the data analysis. Second thing, if you say method biasness is present, by default we assume it's non-congeneric. Okay, so check whether it's a non-congeneric or congeneric. If no difference, it's non-congeneric. If there's an improvement significant, congeneric. Next thing, check whether from congeneric it is only congeneric means effect is there only on the items. Check whether the effect is there also on the construct or not. If it is on the construct, that is called as the model R, otherwise model U. Right, so far? What we will do next? Next, once we establish method biasness present, whatever method, congeneric, non-congeneric, and U or R, whether it is affecting, whatever the last best one is there, take that and on the basis of that, run it, take the values, go for the reliability decomposition. Reliability decomposition means if you look every single one, like play, on the play, there is not the one arrow. Initially, I use only this arrow to check the reliability. Hope you remember what is convergent validity. That is used. Now I am taking value of this arrow also and put in a new Excel file which I have given. The name of file is marker or something. What is the name of that file? It's a comprehensive CFA marker approach comparison. So this is available with my videos. Only thing is you put here in the method loading. So whose value you will put? See, we always check it for a construct. So these are the values of this construct like playfulness, and you will check effect of marker variable on this. When you are measuring for playfulness, the values of playfulness, when you are measuring the value of information acquisition, the arrow terms from marker to information acquisition, those need to be placed here. And then it will give you the updated value of reliability, substantial as well as this. Then if you don't have this, then that is the one. And when you have this method, then these values will change. And this value divided by the original is the percentage. Now we'll go for the third thing. Third thing is this value beta is the value given in this particular case. What about the future? Can it change? So we'll go for bootstrapping, which will give you 95% limits of how lower it can be, how higher it can be. Your job is to restrict all of these to the from marker to all of these values actually to the lowest possible, once all lowest, one all highest, and then check what is their relation R. That is called as the model S. Model S for sensitivity. You will go for the sensitivity analysis and report the values. Whatever values I report, you will go for that. You will not say or selective, I will report this, I will not report that. No, you are not selective. You will report whatever you will get. This concludes comprehensive CFA marker approach. Your questions, please. Okay, people are reduced to 176. I assume by the time I will wind up, maybe 50 or 60 people will be there, because it's getting too much. I understand. That's perfectly okay. So if any questions are there, I will request organizers to open the chat box. And one humble request to all, please don't give any feedback now, because I assume that chat box is only for the question. Don't write any word of appreciation or thank you or something. This simply wastes the time. Write only and only about the question. And if you can put the question like a question, don't write the complete essay. Don't write an email in chat box. Write a very small question, preferably. That will be really helpful. Okay, the questions are, okay. I think Kuldeep has posted the questions. Let me take the questions. If more than IV are there, IV are measured, I think I answered that. You can take marker variable that resembles to any one of these. The question from Senthil, will endogeneity and common method biasness a problem with the secondary data? Answer is, I don't know. My area is only with the primary data survey method. I don't work in that. BST says, is there any good relationship between model fit, goodness of fit, and common method biasness? Common method biasness will affect all sort of the model indicators, not only goodness of fit, it will affect all of these. That's precisely what we are checking. If I have SPSS but not a mouse or smart PLS, can I test common method biasness in some way? Pradeep, might be, I don't know. As far as I have reached, I get the technique of checking common method biasness only in the smart PLS and MOS. There might be technique in SPSS. I'm not aware of that as of now. Is it mandatory to perform all 5 steps? Say yes, ma'am. I have replied, Ramni ma'am, that not only the 5 steps of the phase 1. If common method biasness is present, then go for the phase 2, phase 3 also. If in the first step it says no method biasness present, need not to go for the successive phases. Limitations, will these hint at the limitation? I don't understand that. In case of multiple marker variable, how to handle the common method? Well, okay. If you have taken number of marker variable, I will suggest should not be more than 2, 3, because otherwise there will be a problem among marker variable, multicollinearity will generate. Just like we have gone for one, you go for the second. Just like the same procedure I explained for the one, replace first marker with the second variable. Forget about that there is another marker. Just go first in the all the 3 phases with one and all the 3 phases with the other. And section wise, you need to report the effect of this particular bias is handled by this marker variable and results are this, and so on likewise. How we collect the data about the marker variable in questionnaire? Sonal, are you really listening me? I said this is a decision taken by you. You will see whatever your dependent independent variables are there, a similar in form and appearance. At the same time, you need to write that this is a marker variable I have taken, this is the justification, and you need to give a detail of. Okay, so let's start now of smart PLS software. So let me quickly go to the smart PLS. Where is it? Yeah, there is a smart PLS. So I have the same file. Actually, there is no file in there. That's a good thing. So let's see how to work in the smart PLS. So I have taken a file. You make a new project. With the new project, you import a file. In the smart PLS, we import a CSV file. And now these are my data. The good thing in the smart PLS is you just throw it out and you just throw it out. Okay, now let me change it. So it says right click and rename. Its name is Loyal, and right click rename. Its name is satisfaction. So this is satisfaction. I put it on the right hand side. Satisfaction leads to loyalty. Let me connect it with the arrow and run it. Now, generally people, they have so many details in this, whether you should go for consistent or PLS. I always refer you should go for PLS. But here, let me go for bootstrapping so that I will know what is the effect and whether the effect is significant or not. It's my simple work without any method biasness or something. So bootstrapping, I will go for a small sample of 500 so that it won't take time. You should go for bootstrapping not less than 2000, preferably 5000, but not less than 2000. I am using 500 simply, just it will take less of the time. Otherwise, it will take a lot of time in calculations. My result says that satisfaction has an effect. P-value is significant, 0.595. It's a good effect. I can quickly check my values here. Okay, values AV, etc. are there in the PLS algorithm. Let's run that also. So in the PLS algorithm, let me check these values. The values comes out as all values okay, alpha is okay, rho is okay, composite, AVE, these values are good enough. What about the second thing, discriminate validity? So let me click on the discriminate validity. So this value should be more than this in the Forner and Lacker criteria. Cross-loading, heterogeneity. So you must know how to see that this value should be more in Lowell, less in here. Heterogeneity, all the values should be less than 0.85. This is the graph wise. Okay, all values are okay. Anything else? No, I think it's good enough. Now, whatever your common method variable is there, listen it carefully. In the smart PLS, we work with two methods. Assuming, number one, it's totally different than comprehensive marker approach, CFA marker approach. It has nothing to do with phase 1, 2, 3, etc. That is only for the AMOS. In the smart PLS, how we proceed? We say you measure a variable, marker variable. Yes, I have measured. Rest of the methodology is the same. You measure it along with the rest of the variable. Form and size should be similar, absolutely similar. As many constructs are there, as many marker variable you need to put. So marker variable here also, the same marker variable. So let me name it as M1 and its name as M2. Okay, and I will close it. I don't need this. And you need to put an arrow from every connect marker to this and marker to this. That's it. So as many are there. So take the marker variable separately, not from this. Take separately as many times. So if there are the 5 constructs, there will be 5 same marker variable 5 times. If there are the 10 construct, the same marker variable will be 10 times and connect. That's it. Run it once again and check whether there is any significant change or not. Earlier, I remember it was 0.595, and now let me see how much it becomes. From 595, it has changed to 529. That's it. You will report along with this. Rest, reliability, validity, etc. You will report usual, and you will say this is the real result between the two. So because Smart PLS says it doesn't work on separately for measurement model, structural model. So whatever effect is there, you will find there will be effect of this method bias, and you will report that. That's it, as simple as that, given by Chin. So validity, reliability, I think they are still okay. Discriminant validity still okay. Multicollinearity and check for this. R square will be minute changes there. This is the first one, which says you check it on the basis of construct level. Construct level. So as many construct, the same variable will come as many number of times. So you can see the effect of marker variable on satisfaction is 0.214, and on the second there is actually little high, 0.28. There's an effect, and now there's the relation between the two. The second approach says that marker variable has an effect not on the construct but on every statement. That we will discuss post lunch, because that requires something. So we will use a residual method, but problem will be when you remove its effect, the reliability aspect will also remove, okay, from the residual. So that need to be added back. So I will cover this portion. reliability decomposition, which we have done. 6 things we have done, that what are the advisable initial best practices for marker variable. And now we'll talk about this CHIN approach. CHIN 2013 introduced this measured latent marker variable. Measured means it's a priori. Latent means you will measure it as good as latent. It's not like company size or something. So measured latent marker variable, Mlmv approach. And here what we'll do, we'll simply work on the construct level. So same number of control variable as the number of constructs, and then go ahead. The second is our item level, and that we'll do in the next one. So only 2 more slides are there, and then the concept will be over. So now let me take questions. This is influencing the individual statements. Then how should we proceed? If it is influencing the individual statements, well, in that case, what will happen? We'll assume it like this. It's called ILC, individual level correlation. Now there it involves parceling out the Mlmv items in order to parcel out. Each item measure has to be regressed on all. So we'll find out and we'll use the residual score. That's very simple. So it's as good as partial correlation. Smart PLS gives you not only the score, but also the residual. So residual we are concerned with. So we'll walk and find out the residual. But the problem here is that common method biasness removes the random error also when you take the residual. So we need to replace that back with a random error. How to do that? We will take the R square. We will take the standardized standard error. And using the two, we'll find out a factor, and that factor will be added to the residual. And then we can go ahead with the residual. Let me show you this process. This step, R square, etc. Little you need to pay attention to this particular thing. Let's go for this. So it means I have taken one variable marker and individual statement I have taken. So just put all the statement one by one out. One by one, all the statement. So in case you have the 5, 7 constructs, every statement need to be here. If it's a very messy diagram, then you can close this using Control X. You can close it down in Smart PLS, and then you can put as many circles. And then one is about the marker variable for all. You need to remember that in case of Smart PLS, there is no error term. There is no concept of error term. So you simply go along with it. So let me go now along with it, run it with the Smart as the PLS algorithm. So I'm not going for calculate PLS algorithm. So in the PLS, nothing sets a path by default, the default values. Click on the start. And now you will see that we'll get the value of the here residual. Now these are the value of the residual, and in that, not the outer model, but the inner model residual we need to take. So let me copy in the Excel format. So if you purchase, then that's the advantage. You can copy to Excel format, R format, etc. And you can take it to now Excel. So let me take it to Excel now. These are the residuals I have taken. Now problem with the residuals, from the residual we have also eliminated the random variations. Random effect was there. You remember we started that measurement is equal to actual measurement plus some sort of random variation, which is a concept of reliability, and then something else called the common method biasness. The problem here is that we have removed that sort of random variation also, which need to be added back here. How to add back? So I require the two things. One, find out the R square for all. So let me see the R square. Here we get the value of the R square. These are the value of R square for all of these statements. Take it to Excel. And I don't require R square. I require actually square root of R. So let me do it square root of this value and all of the value. These are the square root of R I have computed. Next, I require the standard error. Now standard error we can get only from the bootstrapping. So come to here, and this time I will go for the click on the calculate bootstrapping. In the bootstrapping, you will find the standard error. So run it in the simple one output here. look at the mean, standard deviation, etc. This is the value which I require. So I'm not really concerned about this. Simply Excel format and take it to Excel here. Now out of it, I require only the standard deviation, not others. That's it. Okay, I have deleted that also. This and this. Okay. So this is from marker variable to loyalty one. Please ensure they are in the same loyalty one, satisfaction one, satisfaction one. Now multiply these two, R and this sigma. Now this particular value need to be like this particular value need to be added in all the terms of loyalty one. So check, this is the loyalty one. So we will add this particular value. So how I go along, I write it is equal to and this value loyalty one. And now let me drag it. I can drag it on the right hand side 1 2 3 4 and drag it down also. I think these are 100 observations. So let me come here. So not this one, sorry. It's starts with the what I'm doing actually, I have just said is equal to this value. So if I drag it down, just say what is this value? This value is equal to B2 value. And what is there in the B2 value? B2 value was 1.46. Okay. So I'm just dragging it to 100. So dragging it down, the shortcut is Control D. That's a down fill. It's called as the fill up to 101. Control D. And on the right hand side, the shortcut is Control R. That whatever value is there, put it on the right hand side. On the right hand side, there is no such thing. Remove that. Okay, this is one I have copied as such. I could have used copy paste also, but the purpose of that was now I will say plus, and this value is fixed for entire column. Control D, so this value changed. In the loyalty to add this one. Now what is this? This represents 0.016. This represents that sort of the random variation which must be there, which we have removed from our construct. Put a dollar means the same value, absolute value. This. So now let me try to do it for all, and one by one, let me make it as 4. Next, it will be 5. Next, it will be 6. So you need to see whenever it's a satisfaction one, so that value need to be added in all. So I'm just changing it. It's a 7, then 8, and then 9, and I will drag it together for all. Okay, and drag it all. Now these are the values I will copy. I will put it into the file, and then I will go back to Smart PLS, and I will make a new one and attach this file. Attach this file. So if you want to see, so just see here, loyalty 1, loyalty 2, etc. These are my files. My raw file will be like this, all these values 0.505, 493, etc. So all these values are there. So you will just have this import, or if you wish, I can show you right from the start. If somebody say I have not seen it, so how we'll start? Click on the new project, give it a name. I'm saying Common Method Biasness underscore residual. Okay. So it says, okay, where is your file? So let me put this into a file, and we require a CSV file. So CSV file has only one sheet. Please remember, Excel file, you can have n number of sheets. In the CSV file, you always have only one sheet. So Control N, and I will write it as paste values. So this is my data set which I require. Save, and let me save it, browse. Let me save it on desktop itself with the name of res or .csv. So we require not the Excel format, we require the comma separated value, CSV, because Smart PLS works on CSV format. Save. Okay. It says, do you want to save it in other format like Excel, etc.? No, I don't want to. Don't save. And this also, the work is over. If I will just explain you once again what I have done. Number one, I have just see it from here. What I have done here, I have made a diagram, common method, the marker variable, and all of the items I have regressed with this. So every single item, because now I believe that there is an effect of marker variable or common method biasness on every single construct. So you run it. Okay, that's a simple regression. So we can get the predicted value of satisfaction. We can get the error term also. So get that error term means what is the residual. So click on the residual here, and residual, not the outer model, inner model residual. This is a residual. So get these values, copy this value. Second thing, you go for the bootstrapping. From the bootstrapping, I require only this column, 0.129, standard deviation. I require that. And here I require the R square also. So get the value of the R square, get its square root, that will be R. R into sigma, that will be added everywhere. So see what I have done. This is my value of the residual of inner model. Now come to this, I have taken R square and done the square root of that, that becomes R. I have taken the value of a standard deviation and then multiplied the two, R multiplied by sigma. And now this value will be added to loyalty 1, all the residuals of loyalty 1. In this, I have to add that. So how to go along with that? I used a function. The formula is I used is equal to that value plus this value. And I put it on dollar. Dollar means when I drag, this value will be only Q2. It won't change. So see here, it won't change. It will always be Q2. That's some of the property of the Excel. Then here I have added this value. I have added this value. All these things I have taken to a new file, and new file I have saved with the name of res. Now I go back here. This work is over. I go CMB residual. It says double click to import the data. Okay, double click. Where is the data? Data is res. Okay. Now without saying anything, it will compute how many missing values are there, sample size, mean for every statement, median, minimum, maximum, standard deviation for all of them. It has computed. That's fantastic. Come back to here. Now you see all the value and see satisfaction. Any method biasness. So Control W on this side. Make a diagram, run the effect, and just see how much is the effect. Earlier effect, I think it was 0.595. Now see if it's reduced or something. 572. Yeah, from 595. Just see earlier its effect was here. If you see, the effect was 595 something, but now we have seen the effect. It has reduced to 572. Okay, this is the t value. So that is all, because we have removed it from actually I have too many files opened here. I think this is the file. So here you can see in the inner model, instead of t value, you can show the path coefficient and the t value. Value is 572 and this is the t value. Or you can see path and this is a p value. So there is a significant effect, still significant, but it is reduced after removing the method variation. So it will show only in the structural part, and then you can cross check using PLS, because that will tell you how much is the change in the AVE and other things. So that you can check how much is the R square. It's 32% now, and likewise check as a reliability validity, still okay. I hope they are a little bit on the downside, but it's still okay. So that is how to remove. So only one technical part is that to take the residual of inner model, take the R square, sigma, multiply R sigma and add it in every variable, every residual. Take the residual back to the file and then start working. So this is all about this approach. So conclude that. Yes, Jubin, please ask your query now. What is the query? Kuldeep, if you can please start the chat box. So with that, we have completed the common method biasness, and now we can go ahead with the second thing. The second thing is about the unobserved heterogeneity. I have put all this, let me show you where you can see that. I know I'm a little fast, though we'll try to put the videos of this workshop also on YouTube. But see, you can simply go for here, YouTube, and you write Neeraj Kaushik common method biasness. So you will find all the videos. I have not actually discussed in much detail In the videos, I have talked it in much detail. The 15 videos are there. In the 15 videos, I have talked all of these in much detail. So what are the weakness of every method? Okay. So these are the methods, and with the view, what I have discussed is okay. Now it's okay. So concept, sources, this is important for you. How method biasness can affect this basically talks about, remember that process, comprehension, evaluation, judgment, then what is mapping with the format and giving the answer. These are the remedies. Two sort of remedies are there: statistical remedy and research design related remedy. Research design related remedies are good. You should include it always at the time of data collection. Discussion of a paper by Dr. Rapsa Gupta, where she has worked on the different sampling units at the different time periods she collected the data. Statistical remedies can be bifurcated into initial approaches, partial correlation, correlation marker. These were not really good. A tale of the three perspective, you gave the entire simulation test they have used to check what exactly is the way out. So this is comprehensive CFA marker approach. Just below this video, okay, this is, I think, the conceptual part. So just below the video, you will find the presentation, and the next video, video number 12, you should find the Excel file also. Okay, so I have provided all sort of the file number 1. So this is the spaces file you can download. So model 1, baseline model, all the MS files are there, you can download. And this is the Excel file comparison for calculating the reliability decomposition. And Excel file comprehensive large version, this is a small version. Both are given, so you can download it from here. So this is video number 12. Then video number 13 is simply some observation on this method. 14 is some guidelines for the ideal marker, 6 guidelines, 2015 it was given. And last one is Mlmv approach, which I discussed about the two, about working on the construct level and working on the individual level. So you can just see here, I explained that part. When we work on the individual level, there is some calculation step. Yes, you need to work on it, and only then you will be able to remember that. So this is one part which I have covered completely.